let's talk about Deno modules, because this is a big topic, one of the most heavily debated parts of Deno. You see, when it comes to modules and the way we handle modules in Deno, it's very different from Node. What do I really mean by modules? Well, modules are just files, TypeScript, JavaScript files. When we build our applications, when we build our code, most of the time, we're not just working by ourselves on one file. We're working with multiple files, with multiple team members. And as projects get bigger and bigger, we need modules. We also use modules as a way to use other people's code, so we don't constantly reinvent the wheel. And instead, we can use the power of the community to build some really, truly great applications. So modules are just files. In Deno's sense, they're JavaScript, TypeScript files. Now, we already saw that with Deno, we import modules using the ES6 import syntax. And we can import them by referencing the URL. Let's dive a little bit deeper into this and really learn about how we can start creating bigger applications with Deno using this import-export syntax. If we go back to our VS Code, we have our simple application that we built. When we run in here Deno, and I use the info command, remember if we do Deno --help, we get a list of commands that we can use with Deno. One of them is the info command, which is show info about a cache or info related to source file being the file that we're working on. So let's try that. Let's clear this and do Deno info and reference, because I'm in the desktop right here, I can just say Deno.js because that's where this file is located. So I'm going to say Deno.js. And it gives me some info about this package. It's a JavaScript file, there's no dependencies, and this is where the file is located. That's great. Let's create another module, another file that we can do something in. So here I have Deno2 and Deno3.js. And let's just write a fun program here. Let's say that Deno2 exports a function, so we'll say export function, and we'll call this dnode. Oh, this is going to be a good one. And we're going to say that input. This dnode function is going to accept an input, and if input, and let's say to lowercase. So if whatever we receive as input, we're going to lowercase it, and if that equals node, so if the user types in node or capitalized node, if that is equal to node, then we'll do a fun little function that will return the input. We're going to split it. We're going to sort. It's going to split node, so it's going to be N-O-D-E. It's going to sort it, which by sorting it becomes D-E-N-O for Deno. And then finally, we're going to join it back up so that it becomes a string again. So essentially, this line of code changes node to Deno using this JavaScript syntax. Let's say if we receive something other than node, we'll just return the input. That's it. And now what we can do in Deno3, we can actually import that. So again, just like we do with ES6, we can just import the dnode function. So let's say import dnode from the file deno.js. So it's in the same directory, it's on the desktop. So I'll say deno2.js. And in here, I will simply say console.log dnode, and I'm going to give it the string node in here. Let's save that and see if that works. I'm going to say Deno run, and we'll give it Deno3.js. Look at that. It's turned node into Deno. If I give it something other than node, let's give it some gibberish, and I save and run this. All right, I get the gibberish back. But it denodes my node whenever I need to. Now, one last thing you may notice here is that I added the .js file, which you might not have to do in Node. If I leave it like this, you'll see that I get an underline. Cannot find module Deno2. And that's because with Deno, you need to explicitly give it a file extension. This is a feature we're going to talk about a little bit more with Deno. Unlike Node, we don't want to just assume that this is a JavaScript file. We want to be explicit and say exactly what file we're importing. So this is something that the Deno package that we installed with VS Code, if you remember, we had the Deno just Javac package. Well, that's what is giving us that little type error. So let's close that. And these are modules, ES6 modules. If you're used to JavaScript, this isn't anything new. This should make sense. What gets really interesting, though, is when we talk about external modules. Let's do that in the next video. Welcome back. Let's talk about external modules when it comes to Deno, because not all files, not all JavaScript and TypeScript files are going to be written by us. Sometimes we want to use other people's code. Now, before we get into that, remember our command, the Deno info, and we give it a file. So in this case, I'll say Deno2.js. If I do that, I see that, all right, this Deno2.js, it gives me some information about it. That's great. But when I do Deno3, remember, Deno2 is just exporting a function. With Deno3, that actually relies on Deno2.js. If I run this command and say Deno3.js, it shows me my dependency. Look at that. Deno3 depends on Deno2. Now, in a similar fashion, I can do that with any sort of module that's a URL. Let me show you. If we go to the Deno standard library over here, and we go into examples, we have the simple welcome.ts. One thing I want you to notice is that all of these are actually in TypeScript files. So Deno recommends that your modules are in TypeScript. So here you can see that it's just a simple console log. If I copy this, I can import it in here. Let's do import like that. Save it. And now if I run info on Deno3.js, you see that? It downloads this file from the internet. It compiles it because it's a TypeScript file, so it has to compile it, turn it from TypeScript to JavaScript, and then give it to the V8 engine. And then finally, we have our file that has 2 dependencies now. Very, very cool. And I can even run Deno info on the URL itself over here. So if I can do this, before I even use it in my code, I can see, all right, this is the info of the package. This is where it's stored locally. It's a TypeScript file. This is where it's compiled. Here are the dependencies. You see that it has no dependencies. And this is the link. So you can find out information about the packages you're going to use. The neat thing about Deno is that any ES module can be used with Deno and the info command. So the Deno info command, even if the package itself doesn't actually use Deno, you can find out about its dependencies. So as you can see here, anytime we include or we import a URL that's a file, a TypeScript file, or a JavaScript file, Deno is going to download the program and compile it, and then runs the code for us. Now, I know what you're thinking. Hold on. We're just grabbing some random script over the internet and running it on our computer. Isn't that dangerous? Of course, you should never do that. If somebody sends you a JavaScript file through email and tells you to, hey, just run this piece of code, well, you probably don't want to do that. Now, we've already talked about this, but the Deno standard library, because we're running it from the official Deno site and the standard library, which we'll talk about, these files, these TypeScript files, are generally safe to run. We can trust the source. We can trust Deno. And remember, because Deno has a sandbox, it prevents program to do anything outside of the sandbox. We have to give it actual permissions. Unless something like the HTTP module requires network access, it's going to give us that warning that we need to allow permissions. Now, this URL is just a file, right? It's hosted somewhere, and welcome.ts is hosted there. So if I type this in to my browser and enter it, I get exactly this TypeScript file. Now, in this case, instead of just showing me the text, it has this pretty little website, and that's because the Deno website knows that you're running a browser and serves you a more friendly looking TypeScript file to show you, hey, this is what this file looks like. But underneath the hood, this is just a TypeScript file. Now, we're going to talk a lot more about modules in this section, but the one thing I want you to note here is that although this syntax may be weird, languages like Go, which are becoming more and more popular, actually use this syntax. It's a very nice explicit way to say, hey, this is where I'm running my code from. And this way you can actually check out where this code is coming from. Do you trust the source? Do you trust this code? Does it have the dependencies that you trust? And by being more explicit, that is to be really clearly saying, hey, this is where the code is coming from, we can generally be more secure. And Deno, when it comes to security, has that principle in mind. All right, let's explore some more Deno modules. So here's a fun fact for you. I told you that Deno was written in Rust, but when Ryan Dahl first started working on Deno, he actually was trying to write Deno with a language called Go. Now, because of what he wanted to do with Deno, they ended up switching over to Rust. However, a lot of the principles are inspired by Go because Go is a very nice language. And because it's newer, it's able to have some really interesting concepts based on what we've learned in the past with languages. So it's a very clean, nice language to work with. In the same sense, Deno has some inspirations from Go. We already talked about the modules and the URLs, but this idea of a standard library is also inspired by languages like Go. It's also something that we have had in languages that are older as well, such as Python or C. This idea of a standard library is really, really interesting. Again, something that Node doesn't really have. Whatever is in the standard library is officially reviewed by the Deno team. Each of these modules don't have external dependencies outside of the standard library. For example, the HTTP library or module has some dependencies, but these dependencies are actually contained within this package. So if I copy this server.ts, I go into our terminal and I do Deno info server.ts. It's going to download, it's going to compile the file, and then it's going to say, all right, here's the dependency. It's pretty big, but as you can see, all of them are within the standard library. So this package we can trust because it has no third-party code. That is, no random person writing code for it. It's all approved packages. Now, this idea of a standard library is really nice. JavaScript never had a standard library. And what that meant is that users have been forced to just reinvent the wheel again and again. For things like UUIDs, which is a way for us to generate unique IDs, there's so many packages on NPM on generating unique IDs. So when you go to NPM, you have to decide which one should I use, which is the best one. Instead, Deno just says, hey, use this one. This is the official package for UUID. No more questions about it. When we have third-party packages like React, Angular, and all these frameworks, especially when it comes to front end, that's a good thing. You want to have choices in your modules. You want to have pros and cons and decide on the tools that you use. But for simple things like UUID, like HTTP server, things that are very common that a lot of people use, it's way better to have an official standard library so that there's no doubt about it. You should just use this one. And these libraries are all pretty small so that they can act as building blocks so people can build things on top of them and improve them and customize them, but with the underlying core being the same across all Deno projects. The last thing with the standard library that is really, really nice is that this is going to be maintained by the Deno team. It's not going to go away. It's not going to disappear from the website. It's going to be actively maintained, and we can trust that whatever in the standard library is a nice, long-lasting package that we can trust will be running for many years into the future. So that's the standard library. But what about third-party modules? These are the modules that other people outside the Deno team create for us. Let's learn about those next. This is an important part. Deno third-party modules. The reason Node grew to such a large community, to such a in-demand skill, was because of the community that evolved around it. I've already spoken about the fact that when we have a new technology, the success isn't always about, hey, does it have all the best features? Sometimes it's all about the community that forms around it. If people are writing Deno code, Deno modules, the community is growing. That is going to dictate the success of this project. So when it comes to third-party modules, you and I can create them for Deno. You might be wondering, at the end of the day, this is all JavaScript. Can't I just use whatever NPM module I want and just use it in Deno? Wouldn't that just work? Can't I just go to NPM and do that? Well, let's think about this. Would that work? Would an NPM package work on Deno? It wouldn't necessarily, right? Remember, one of the biggest issues with Node was that it was created before we had ES6 modules, before we had the import and export statement. So one of the main breaking changes in Deno from Node is that Deno doesn't understand common JS pattern. It doesn't understand the fact that a require keyword imports something because, well, it uses import and export. So an NPM module that is written for Node that uses the require statement, Deno wouldn't understand. Another thing is that Deno requires a file extension. So any Node NPM package that doesn't have the file extension, let's say in the piece of code it imports something even though it uses the ES6 import statements, it doesn't have a file extension, that's going to break. Node.js at the end of 2019 finally enabled ECMAScript modules, right? I believe it was version 13 of Node that you can now finally use import and export statements in Node. However, it doesn't require this extension. So a lot of the packages on Node probably won't work on Deno unless the library authors actually fix those things to be also compatible with Deno. However, a lot of effort has gone into developing these packages. For some of them, it's not that hard to make them compatible with Deno as well. And you'll see many here that also exist on NPM and that work on Node. Now, we're going to be using third-party modules in this course. One of the ones that we'll be looking at is the Oak module to build our application. But you can see here it's a middleware framework for Deno's HTTP server, which we've talked about. That's a standard library that includes a lot of things like routing for us. So you can use here to search, and you can even add your own libraries here to the Deno land third-party modules by adding this to the database.json file that they have, and expect this community to really grow over the next couple of years. Welcome back. I want to talk to you about this idea of caching that Deno has built in. If you remember, our Deno3.js file imports the dnode function and also imports this welcome.ts file from the standard library. And then we console log dnode. Let's do Deno run, and then we'll do Deno3.js. It's going to download this welcome.ts file and then compile it because it's TypeScript, and then it's finally going to run the command. This thing that we just downloaded, where does it live now? This actually lives on our computer because if I run this script again, you'll see how much faster that was. I didn't actually have to download it all over again. And this is because of Deno's caching. And caching just means storing some data that we've already seen before. So what Deno does, it downloads this file, welcome.ts, so that next time we need to use it, it doesn't go over the internet and have to download it. Instead, it's going to look on our computer and say, oh, we already have this in our cache. So where is this? If we go to the documentation and we go to linking to third-party code, we'll see here if we scroll down that Deno caches remote imports in a special directory specified by the Deno dir environment variable. Now, if you followed along during the installation of Deno, you know that we were touching the Deno directory environment. But you can see that depending on your operating system, so if you're on Linux, this is where it'll be. On Windows, you'd have here. In my case, it's on Mac OS, so it's at this location. So if I actually copy this and you go to your home directory, into the library and caches, again, if you're on Windows, it'll be in this location. I can open up that file. Let's do open, like this. Now this works because I'm on a Mac. You can just manually go to that file. But you can see here that this is my cache folder for Deno. Anytime I import something externally over the internet, it will save it here so that I don't have to download it again in the future. If I delete this, let's move it to trash so it's completely empty. If I now run Deno run again, it's going to download because there's nothing left in the cache. Let's say you want to manually reload something. Maybe something has changed and you want to still download it even though it's in the cache. Well, you can just use the reload command. So I can just do -- reload, and it will download the file all over again. Why is this a neat feature? Because now this code is going to work Let's say if I'm offline, maybe I'm on a train or an airplane. In that case, my code, as long as it's cached, doesn't need an internet connection. I can play around with this code, and because these files are in my cached folder, it's going to work without an internet connection, which is really, really cool to think about. The key to remember here is that Deno caches our packages in this Deno directory that we set. So Deno dir is an environment variable. And we're going to talk about this a little bit later on. But this is something that you can set yourself. When you install Deno, this is set automatically for you. And we saw that in our install video. But there are ways where you can actually change this and actually have Deno cache these files wherever you want. Again, we'll talk about that shortly. But for now, let's take a break and let's explore some more in the next video. Welcome back. Now, you might be asking yourself, what happens if the Deno.land website goes down? I mean, that's where the standard library is. And these standard library modules are going to be used by a lot of people, by a lot of projects. If it ever goes down, isn't that bad? Wouldn't all the code break? And this is actually a problem that any dependency system really encounters, right? Same with Node, same with any time that we require or we need a file from another source that is over the internet. If a server goes down, if the internet connection is down, then we can't use those files. Now, in a place like Node, we avoid this by downloading our packages, our dependencies in the Node modules folder. But in Deno, as we saw, we're able to download. Once we run it once, we're able to cache a lot of our dependencies in the cache folder, in the Deno dir location. And remember, the Deno dir location was where our cache is located. So if we go to the documentation, we see that Deno caches remote imports in a special directory specified by the Deno dir environment variable. So the default directory is dependent on what system you're running on. So you can check it out by going to the linking to external code and linking to third-party code over here. They'll tell you where that cache is. If I open this, this is where my cache is. If I do open, instead of home, do Deno dir, it does the same thing. So that's where we're able to store our files. If we're ever offline, if we're ever on a plane, we can just download them here. But what happens when it comes to production? When we don't want our files, when we release them to production, to have to depend on the internet to download these scripts? What's the best practice here? Now for this, I'm going to use a sample application that we're going to build. And we're going to use the Planet CSV Deno that we'll build in the course. And here you can see that Adam has already put it up on GitHub. I'm going to copy this code. I'm going to git clone this. And now I'm going to move into this folder where the project is. Let me clear here. And I'm in the Planet CSV Deno. If I open this folder, you'll see that I have a few files here, one being the mod.ts. If I open this up in VS Code, you'll see that this is the code that we use for this project. And it has a bunch of dependencies from the standard library. So when I run this code, let's say Deno run mod.ts, it's going to download all these things. And I also get a permission denied because it's requiring a read flag. But for now, we don't need to worry about that. We just need to know that these dependencies were installed. But they were installed on my computer. What happens if I want to put it on a different computer? Well, I can do this. I can create a new directory, and let's call this the Deno directory. You can name it whatever you want. So now we have the Deno directory in here. And this is empty right now. Now, if you remember, our Deno directory is where we get our files cached. So I can actually change this. If I'm in this project folder, and then I'm using the fish shell, so in order for me to set the variable, set an environment variable, I have to do set Deno, and then we're going to set Deno directory as /Deno dir. Now, if I press enter here, our Deno directory is now where the Deno directory variable is set, and I can run Deno cache and the mod.ts, which is this one, to cache these files. So now, if I go here, you see that the Deno dir has these cached files now. Now, this way of setting the environment variable, where was it? Here, really depends on what command prompt you use. So I use the fish shell. If this was, let's say, using bash, in your case it might be bash, you might have to do export. Or if you're on Windows, it might be different. The trick is to just Google command prompt set environment variable. So based on what you're using, you're just going to Google, and we just click on one of the answers. You see here that, okay, we do this set syntax like I did with fish. If you're on bash, let's do bash, how to set environment variables in bash, and there we go. We use the export syntax. So don't be too intimidated by this. All I'm doing is saying, hey, I want to change where my files are being cached. Now, why is this useful? Well, if we go to the Deno documentation in the linking to external code, this is actually one of the recommended ways for you to do so. We've set the environment variable. We've run the Deno cache, and then you want to cache and run whatever file. In our case, it was mod.ts. And then once that's done, we can actually add it to our GitHub directory. So we can add the Deno dir that has our dependencies, and we can commit it to our GitHub. So with Deno, you can put the cache dependencies and put them up on GitHub, so you don't have to install them again. How cool is that? So if we go back to our Planet CSV, if I run this now, let's do Deno run mod.ts. It's compiling it because it's TypeScript, but it's not downloading anything because now the Deno dir folder has all my dependencies. So I can now actually include this folder in GitHub so that others might be able to use this without having to download my dependencies. When I release to production, I might want this folder in production so it doesn't have to rely on downloading these external packages. How cool is that? Welcome back. Now we just learned that with Deno, we don't really need NPM. I mean, sure, we have the Deno third-party modules that are hosted at deno.landx, but theoretically, anybody can host any file that they want, and there's no central place to host your files. This was one of the main reasons that Ryan Dahl wanted to create Deno, this idea of decentralization. As a matter of fact, NPM has a lot of people complaining because of this idea of centralization, and a lot of issues in the past that have formed because of this one entity that controls NPM. And things like Entropic have come out to make sure that NPM and the packages that people share aren't all going to be on NPM and have this centralization. Now, Deno, by allowing these URL imports, by not having an NPM, allows us to have no package manager and having to rely on URLs to host and import packages. Now, this makes it super flexible. As library authors, we don't have to always just publish them on NPM. Eventually, there will no doubt be a central repository so that you can discover Deno packages. Maybe it'll be on the Deno website. Maybe somebody will create it. For now, you can find packages over here on the Deno official documentation website, but Deno also recommends checking out Pika or Pika CDN. Now, at the time of recording this video, Pika is a good way for you to discover Deno modules as well. Now, any package available on NPM is available on Pika. What Pika does, or the Pika CDN does, is it automatically converts the NPM modules to work with ES6 imports. So you can see over here, I can import Preact, I can import Redux, Async, all these tools using the import statement. And you see over here that you can load any NPM package anywhere, even Deno. But for now, you can use these two sources to find out about what packages are out there. And as time progresses, we're going to get more and more packages, and the community is going to grow more and more. I know what you're thinking. All right, Andre, I get it. I can use modules that other people wrote, and I can develop my applications. But I'm still not convinced. There's still a few things that are missing. What happens if a package gets updated? What if I need a specific version of a module? What do we do then? Don't worry. Deno has you covered for that as well. When it comes to versioning, that's really, really important. That means, hey, what version of the module should I use? All of these modules get constantly updated because, well, new security vulnerabilities are discovered, new updates need to be made, and as programmers, we know that scripts are constantly being evolved to become better and better, to fix bugs, to add new features. Sometimes you need to update things for security reasons. Sometimes you need to update things or even downgrade things so that modules work together. So how do we do this in Deno? It's quite easy. Let's say I wanted to use the ABC Deno framework to create a web application. If I click on this and I scroll down to the README, we see here that all we need to do is import the module, and you'll notice here that a lot of these modules will have mod.ts. That's actually a Go language convention, mod for module. So a lot of these modules will end with mod.ts. So here we see that it's the ABC package, but then it has this, the @ sign with the version number. RC stands for release candidate. So that means the latest version is version 1.0.0 RC6. Again, if we click over here, we actually see all the versions that have come before it. So if we wanted to, let's say I wanted this version that was an earlier version, I scroll down and now this has changed. And let's say if we want a specific version, one of the first versions of ABC, you see that once again it's different, mainly because the library authors changed the way that this file exists. But this was written before the convention of Deno started. Now, the way you import and version files is using this @ and the version number. But most of the time, you can go to the repository and choose the version. Let's pick another package. One that we're going to use in this course is a framework called Oak. And with Oak, we're going to build a real-life application. But when we actually install Oak and use it as a dependency on our project, we want to make sure that we use the right version. Now, if we don't specify a @ version, it's just going to download the latest version. But for some reason, let's say you're watching this video in the future and you want to match our version, in our case it's version 4, which is the latest. But let's say you want to downgrade now to version 3. We now have to do @ version 3. So I can copy this code right over here and I will just import this specific version. And if you remember, each project can have its own packages. So instead of having all the packages or all the modules in that home cache directory, Deno directory that we spoke about, you can now create one specific for each of your projects. So if you remember, if we go into the planets, CSV Deno, we have our own Deno directory where we can install a specific version of, let's say, Oak. So I can just install Oak and the specific version using the @ sign like this. So again, the beauty is that if for each project we have this Deno directory that downloads the specific code, the specific version, we can make sure that our code always works with the exact versions of packages, of modules that we need without even network access. Very, very cool. Now, quick note here. Maybe you caught something. If I ran this, what do you think will happen? If I run, let's go back here and go to Deno3.js, and I'm going to say Deno run Deno3.js. I get an error. Thread main panicked at bad file URL for file. And that's because we don't have an extension here, right? We need to add extensions to our files. So again, if we go back to Oak, we see that we need the /mod.ts. So if we go here, add /mod.ts, run it again, it now works and downloads all the packages that we want. And you see here that it's downloading version 3.7 as we specified. I'll see you in the next one. Bye-bye. Welcome back. If you've gotten this far, you are probably interested in Deno. You are starting to see the power and the simplicity of Deno. For example, I've been working with Node for a while now. The things that were hard with Node become really, really easy with Deno. What we've learned up until now releases us of a lot of headaches that we had with Node. For example, I have a package here from Microsoft. So Microsoft has a TypeScript Node starter. Essentially what we have with Deno, right? We have a TypeScript compiler and a JavaScript runtime. So if we look at this project, we have a lot of things. We have our testing with Jest. We have things like package.json, package lock. We have our TypeScript configuration. We have our test files. We have linting. We have all these things. that all Node projects have. And one of the biggest problem with Node right now is this thing that everybody keeps making fun of. You may have seen this image before. The heaviest object in the universe is this Node modules folder. What do I mean? So I git cloned and I have this TypeScript repository, this Microsoft TypeScript Node repository here. And we have all the files that we saw on GitHub. One of them being package.json. And this package.json, well, this is where we declare all our dependencies of the project. You see all the dependencies here. It's quite a big one. And then we also have developer dependencies. Again, it's a massive file, almost 100 lines with all the versions that we need. Now, this is the main reason behind Deno and what makes referencing via URLs so powerful, right? If we go to our source folder and we go to app.ts, remember, Node and Deno are incompatible because of the common JS module.exports that we usually have in Node. Now, although this project, if we go into source, into app.ts, uses ES6 module imports, you see that it still gives me an error because it cannot find module. We need specific URL. We need file extensions for this to work. They're not really compatible. With Deno, there's no magic behind it. There's nothing in the background that's figuring out where this exists. We are being explicit. We're saying, hey, this is where the module lies. Go and grab it. And as developers, when we come onto a project, it's nice to be able to know where to look, where this package or module is coming from. Now, the beauty of having this is that we no longer need the Node module folder. So usually what you do with a project is you would clone it from a repository. If you were using Node, I would go into this, TypeScript, Node starter, and then I would do npm install. And this npm install would go through package.json and install every single dependency that we see here and create our Node modules folder, which is going to pop up as soon as this install ends. We see that we have our Node modules folder, and this Node modules folder has a ton of things. As a matter of fact, if we do get info, we see that we just downloaded 226 megabytes on disk just for this one single project. But now the beauty is that we don't need a package.json file. Package.json is not really a JavaScript standard. It was created by Node. It was only created because we just needed ways to install dependencies because of the way Node was created. So when it comes to dependencies, we already know how to manage them, right? We have our URLs. If we download the same package for multiple projects, they all live in the Deno directory cached environment, so all of my projects can use the same package. And if I ever want specific versions for different projects, then we just create that Deno dir directory inside of the project, so each one gets its own. So similar to Node modules, but instead, we're not downloading these massive repeated libraries for each one of our projects. Now, package.json has also become really, really bloated. If you look, it's not just dependencies. We also have things like information about the author, licenses. We have things like npm scripts. Now, although not all functionality of package.json you can now do in Deno, things are going to change and we're going to be able to do more and more things with Deno. One of the things is running scripts, which we're going to get to. But I want to take the next video to tackle a problem that you might see and a best practice when it comes to working and replacing package.json in your Deno projects. Let's have a look. Welcome back. When we get to our final project, we're going to build a NASA mission control using Deno project. It's going to be really, really exciting, and we're going to do a lot of things to get it production ready. But one of the things that you really want to do when it comes to Deno is work with your dependencies. This project, if I go to the source folder, will have all our code. And as you can see, it's in TypeScript. But one file that I want you to take a look at is Deps.ts. Deps stands for dependencies. This is a best practice when it comes to working with Deno. This Deno convention is for package versioning. For example, we see here that we have some standard library dependencies, and we're just importing them. Nothing crazy, we've seen this before. And then some third-party dependencies. In this case, we're importing the Oak framework. Now, why would we do something like this? Well, if we go back to our main.ts, we see that we now import not from a URL, but from a relative path, from our dependency.typescript file. And the reason we do this is so that we only have one single location where our dependencies are located. So that if we wanted to change, let's say, the version of the module we import, we don't have to go through all our files and import and change every single URL. Instead, at the root of your project, you would usually have a dependency.ts file, and this file imports all your dependencies. So kind of like a package.json file, right here, we have the TypeScript file that specifies the dependencies. And this way you have one central location, and it's all just JavaScript. It's not a bloated package.json, just nice, clean syntax. You know exactly where your packages are being installed from, and if you ever need to update packages, you just change one location with the @ sign that we've seen. So instead of telling NPM which version of a module to download, instead of running npm install, it's all right here. We just simply run our Deno program and it looks at our dependencies. How nice is that? Okay, but now you're thinking, what about locking a version? Let's say Oak updates. I'm going to install the latest version of Oak and maybe it will break the rest of the project. Is there a way to lock these dependencies so that right now we take a snapshot of our working app and the exact versions of our code? For example, when it comes to Node, we have the package lock.json, and this locks the version of our packages and our dependencies so that we make sure that this exact versions are the ones that we're going to use. Well, with Deno, you can actually do that. Let's take a break and I'll show you in the next video. If we go to the Deno documentation, there's a section, let's see, where is it? Where it talks about how can I trust that a URL doesn't change. Imagine the Oak framework or any URL that you import. Somebody takes control of that server that's hosting that file and changes it to malicious code, let's say, that tries to access information on your computer. Well, first off, Deno is going to have a security flag that says, hey, this file is requesting file system access. Do you want to allow it? But what if the previous version of the URL, you already gave permission for accessing the file system? Well, in that case, and many other reasons where you want to keep the same version, you can use this lock flag to actually do this. And Deno actually gives a very good breakdown of how to do this and using a lock.json file. But instead of just reading this, let's actually do it on a project. Now, let's go to our final NASA Deno project. And I'll link to this project in the resources. I'm going to copy this, and I'm going to just clone this. So I'm going to say git clone and clone the repository. So now if I go into my NASA Deno project, I have all my files here. As you can see, I have all the projects, but I want to make sure that my versions are locked. That is, if Oak ever updates. I don't want the latest version of Oak. I want whatever version I have now. And again, I want to emphasize that this lock is really useful to make sure that whatever package worked beforehand hasn't been tampered with. Maybe somebody modifies a script on a package that is very popular and now tries to do something bad with it. This is a good use for lock files. So again, just to emphasize, the lock file allows you to make sure that the module you downloaded initially is identical to the original download. If I share this project with somebody, let's say you as a student, and you're downloading it, by having a lock file, you make sure that you download the exact version of the modules that I used when I built this course. So how can we do this? The first thing I'm going to do is create a lock.json file. So because I'm using a Mac, I can use the touch command, but again, if you're on Windows, you can just create that file. You just want to name it lock.json. So now if I look at what I have my lock.json file, but it's completely empty. If I go to my desktop and look at NASA Deno, you see that I have the lock.json file. If I open this up in VS Code, it's completely empty. There's nothing there. But now I can do something really interesting. I can say Deno cache, and I'm going to run the --lock because I want to lock my dependencies. And that's going to lock it in the lock.json file. And then where do we get the cache from? What do we want to cache? Well, we want to cache what we had in the NASA Deno project. So if we go back, you'll remember that inside the source folder, we have our DEPS, our dependency TypeScript file. Remember right here, these are our dependencies. So I'm going to say source/dps.ts, because that's where it's located relative to where I am. I'm inside the NASA Deno folder, and inside of that I have the source, and then there I have the dependency TypeScript file. If I run this, it's downloading all the dependencies. Oh, and we get a little bit of a cryptic error. And here we just want to always make sure that, well, we read the documentation. If we go back in the documentation for Deno, we see that I had to do Deno cache --lock lock.json, but then I forgot the lock write to the file. So again, let's just copy this. So same command, except this time I'm going to have --lock write. If I run this, there you go. Now if we go to lock.json, we see that it now works. So I'm actually just going to drag this to the browser just to see it, and there you go. These are our dependencies. That's now part of lock.json. So now Deno lock keeps these copies that we trust. These are their versions. It even has hashes over here to make sure that nobody tampers with them. And this is now what we use to install. So if you find a lock file on a Deno project, by using this, you make sure that you use the same version of the modules and dependencies that the instructor or the coworker has used. So once again, just like we had with the TypeScript Node project that Microsoft had, we now don't need a lock file anymore because Deno has its own version as well. Very, very nice. All right. So we now know how to update packages. I mean, we still have a few things to cover, but what about Deno itself? I mean, Deno is still fairly new, but new versions are going to keep coming up. For example, right now as I'm recording this, version 1.0.1 just came out. So if I go to my terminal and I do Deno-V, I have Deno version 1 on my computer. But what if I want to upgrade to the latest version? Maybe there's new features of Deno. Well, we can just run the Deno Upgrade command. I can just do Deno Upgrade, and that's going to upgrade the latest version of Deno. And there we go. If I do Deno-V, we have the new Deno version. If you're thinking, Andre, this stuff is way too easy, why are you showing me this? Well, this is Deno. It's very nice and user-friendly. Everything makes sense. Everything works nicely. So we know how to update modules. We know how to update Deno. We're getting closer and closer to having the tool belt complete to really start building our applications. I know we've been talking about modules a lot, but dependencies and modules are a big topic in programming. So just a few videos left, and I promise we're going to start building some exciting things. Let's get started. Now that we have an understanding of Deno modules, and the reason we've spent so much time on modules is because this idea of dependency management, of using modules and packages from across the web, is a pretty big topic and a very important one for all programming languages. And I hope you're starting to see the beauty of Deno, of how it simplifies some of the things that we had, let's say, in Node with package.json, with the Node modules folder, and making things clean and nice. So to review for some of the things, usually when we have a project, we would create a dependency.ts file that exports all of our dependencies. That is, what standard libraries are we going to use? What third-party dependencies we're going to use? And this way we can use it in the rest of the application that we're building, but it acts as a package.json file that you might have had in Node, where as long as we need to update something, we just do it here. We also have this idea of mod.ts. Think of this as index.js or index.ts files that you might have seen in Node. Unlike Node, Deno doesn't treat index.js or index.ts in a special way. And if you didn't know this, yes, in Node, index.js is seen as an automatic entry. Now, there's no magic behind Deno. There's no confusion there, but there is a standard. It doesn't do anything special other than as a community, we decided that mod.ts is usually the entry point to a file. So for example, when we import the log module, we import it using the mod.ts. If the log module had many files, usually it would have mod.ts as the main one that imports all of the other dependencies. Now, this mod.ts is actually a Rust convention because, again, Deno was written in Rust. This is just the convention in Rust, and we just mimicked it. And unlike having index.js or index.ts that had a lot of magic behind it with Node, with Rust, we just know that, hey, this is just a mod.ts file. No magic, but this is most likely the entry point of the app. For example, if we go to Planet CSV Deno that Adam created, you see that he has a mod.ts file. This is the main entry point of the file. Finally, we learned that the node modules folder that we may have seen in, let's say, a node project, like this one over here with massive amounts of things, we now have the Deno directory, our cached version on our computer. And if we want, we can even include the Deno directory, the cached libraries to source code, to GitHub, if we want to make sure that, let's say, we release to production and we don't want to install or download all of these dependencies during production. Finally, we learned about the lock files and the way we're able to lock things and make sure that we're using a specific version, or whoever uses our package, our app, our tools, use the same version as us. So a lot of functionality mimics what we had in Node, but a little bit cleaner. But there's one last thing, because in the package.json file, when it comes to a Node project, we had the npm scripts, a way for us to do things, run scripts, run commands, build projects, run server, even run tests. Can Deno do that? Yes, it can. Let's find out in the next video. Welcome back. Now, tooling is an important concept when it comes to programming. JavaScript's popularity really took off because anybody can write JavaScript. You can open up a browser and write JavaScript, and you can start building websites really fast. But because JavaScript is so simple to get started, so easy for people to pick up, well, kind of easy, JavaScript has really grown in tooling. There's so much tooling around JavaScript. If you're ever a front-end developer, so you're working with things like React, Angular, Vue, or any other framework or library, you have to learn how to use Webpack. You have to install testing libraries like Jest. You have to lint your code. You have to format your code. And there's libraries and libraries that you would have to use as a JavaScript developer. And those choices are awesome. Having choices and ability to pick and choose what you want your environment to look like is great. It also leads to a lot of confusion. Everybody does their own thing. If you've ever had to configure a Webpack configuration or needed to bundle hundreds of your JavaScript files, it can get really, really tough. And in the front-end world, things like Create React App or the Vue CLI. This chaos that developed with all the tooling has really gotten people a little bit tired. Wouldn't it be nice if we just had everything standard built in? Instead of having to decide what testing libraries to download, what formatter you should download, what linting to have. Everything is just built in. Now, Deno takes an interesting approach here. What if we had all of these things built in? We don't necessarily give you a choice. Instead, here are the tools that you should use. Now, as of recording this video, this might change, but on their documentation website, Deno has a bundler, a debugger, inspector, a documentation generator, a formatter, a test runner, a linter. All of these things are built in. You don't have to install anything. You don't have to download anything. They're already there for you to use with the Deno command. So Deno is this entire ecosystem in itself. We all agree as programmers, hey, these are the tools that we're going to use. And because we're all using the same tools, we're going to standardize things. Things are going to be a lot easier to digest. When you go on a project, a Deno project, it's going to be really easy to jump on board because all the tooling is the same as your previous Deno project. And this way, we make sure that these tools, these built-in tools, are updated and kept standard with Deno runtime. So let's start using some of these features. Let's look at the bundler. If I click on the bundler, you can see that I can bundle. So I can run Deno bundle and the URL, and will output a single JavaScript file, which includes all the dependencies of the specified input, just like that. So let's try that. Let's run Deno bundle. Now, if you remember, I have my Deno3.js and Deno 2, that is the denote function. And we're importing the welcome.ts. So if I do Deno bundle, let's just try doing it with relative paths. So I'm in the desktop. Actually, I'm in the different project, so let me go back, make sure I'm in the desktop here, and I'm going to do Deno bundle, and I'll do the Deno2.js and Deno3.js. If I run this, there you go, bundling file. It bundled my file, it emitted a bundle to Deno3.js, and it even shows how many bytes. Now, if I look over here, I have a bundled file. There's a bunch of gibberish in there, but there's my code. The way I ran this command, what happened was Deno2.js got bundled into Deno3. This is not what we wanted. Because, well, this is the input URL, and this is the output URL, or the path. So what we did was, hey, bundle this Deno2.js, look at whatever dependencies it had, which is, well, none. We're not importing anything. We're just exporting. And then bundle it into Deno3.js. So that's not what we want, right? Instead, let's go back. I'm going to say Command-C. So we're back to what we had before. I'm going to save. And instead, our entry point is here, right? Deno3.js, because this is where we import Deno. It's going to import Deno2.js. It's also going to import this welcome.ts, and then we're going to console log. So instead, because this is the entry point of our file, this is the file that has all the dependencies linked to it, I can do Deno bundle, then do Deno3.js, and then the output would be, well, it could be anything. Let's just name it Deno.bundle.js. If I run this, it's bundling my file, and now it was emitting Deno.bundle.js. So if we go back, I now have a Deno.bundle file on my desktop, and here it is. And it's all bundled up for me into one single file. So I can actually run Deno.bundle now. So let's do Deno run Deno.bundle.js. And look at that. It runs the file for me without needing Deno3 or Deno2. So there we go. The function that you had with Webpack, it's right there, nice and clean. We have a bundler. That's great. This might be really, really useful when we have hundreds of JavaScript files and we just want to bundle them and send this one to production, just one single file. Let's take a few more of these in the next video. Let's see what other built-in tooling comes with Deno. We have a debugger, which we'll talk about later on in the course when we talk about debugging. We have dependency inspector, which we've already seen, the Deno info command. Let's have a look one more time. If I do Deno info, and I can do any URL here. So let's just say that the welcome TS, I can do, what are the dependencies here? Well, here you go. There's no dependencies, but here's some info on the file. And I can also do this for Deno3.js. So let's do Deno info, Deno3.js. There you go. And it shows me my dependencies as well. So that's really good. We also have documentation generator, Deno doc. Let's have a look at this. Now, Deno uses something called JSDoc as a way for us to generate documentation. Now, you can see here that they haven't actually written the manual yet because Deno is fairly new. By the time you watch this video, I'm sure that they would have finished this. But let's just run the Deno doc command with --help and see if it does anything. All right, it looks like it gives us some information on how we can run the Deno doc command. So it shows documentation for a module. Now, I won't go into details here because the way you document your code is up to you. I will link to the resource where you can read more about JSDoc, but essentially this allows us to comment our code and document our code so that, let's say when we hover over something, we get nice completion and information about what Deno does. Another one that's really exciting is the Deno formatter. Now, if you've ever used Prettier, for example, in the JavaScript land, Deno formatter is kind of like that. It formats your code so there's a standard look to everything. Let me show you. Let's clear this. And let's just move some things around. Let me just do some weird tabs like that, maybe some spaces. This code is still going to work. It's just formatted a little bit weird. If I save this file, check this out. Did you see that? It was automatically formatted for me. Now, this is because I downloaded that Deno package when we first started the course, this one. But Deno does this automatically from the command line as well. So I can run the Deno format command and run it on, let's say, Deno2.js. And it's going to format my code. In my case, the extension does it for me. But let's just disable the extension. I'm going to say disable. Okay. And now I'm going to just move some things around. Oh, I got to reload it. And there you go. Perfect. So if we look at the extension, we don't have any Deno extension enabled. I've messed up Deno 2, and I've messed up this. Let's do some like that, weird format. If I save this, and I run Deno format Deno3.js, check it out. It fixes it automatically for me, and I can also do multiple files. So I can do Deno2.js, and that will be fixed as well. The formatting actually over here, if we go back, it looked like this, and with the new formatting, it fixes it. Now it keeps these spaces because, well, the formatter that it uses sees that I want it to have multiple spaces, so it's just going to follow this convention. But it cleans up and formats our code for us. And if you want to read more about the formatter, you can check it out here. Most of the time, your editor will take care of this, but it's nice to know that in the Deno world, everybody will be using the same formatter so that the code looks the same, the styles look the same. Now, underneath the hood, it is using, for now at least, something called Prettier. It's a code formatter that is very popular with JavaScript, and they're essentially using the rules over here so that there's a standard way that we format our code. Now, as you can see here, Deno lint, or a linter for Deno, is also coming soon. So by the time you watch the video, you'll be able to also lint your code. And also we have a test runner, something we'll talk about later on in the course. The beauty is that all of these things you don't have to install. They are there for you to use. When you download Deno, the Deno executable, it comes pre-built. No npm install, no setting up required for yourself. You can customize these, so you can configure these. But all of these are in there for you. Tools for us to use and standardized around. Very, very cool.